Good morning, everybody. I'm really psyched to be here. It's my first keynote, so I'm not sure if I'm doing this right, but bear with me, and we'll try to get this together. Since it's the first one, and my clicker, of course, stopped working. Keyboard setup assistant. Okay, now it works. Yes. Since it's the first one, I thought you're entitled to a bit of a backstory. So you heard already some interesting, maybe or may not true facts from Martin. But I thought I'll give you a bit of a background. So I started life as a computer person with something called LAMP. Who here has worked on that? Okay, that's a lot of people. I think we can safely call this the sort of the database driving school or something like that. Like where you have this stack that now is like lost to history, where you have, although I think Facebook's anyway, Linux, Apache. Note how Apache meant the web server, nothing else, which in my opinion should have stayed that way. MySQL and the PHP as a sort of stack of stuff to build dynamic websites with. It was jolly exciting, right? And I always was drawn to this like MySQL thing there. I was so drawn to it that this was my actual license plate back then. Because I happened to live in Stuttgart, that asked us like given the rest is kind of funny. And I liked this MySQL thing so much that I ended up studying computer science. And eventually I went to Berlin to study to hear lectures.
We will need to change your microphone because
it doesn't work.
The battery lasted this long.
Oh, okay. Okay, now it works. Yeah. All right. So eventually I went to Berlin to study computer science, and I got a lecture about databases from Professor Freitag, who is here. But then the career took a bit of an unexpected turn, maybe, because for my PhD, I worked on this. I don't know what it is. Is that somebody else?
No. Turn off your microphone, please, in your pocket. Like turn that off.
That one.
Just keep the handheld on, yes.
Turn that one off.
Yeah.
All right. No. So the PhD ended up being on a quite obscure topic, and I think as PhD topics goes, this is a wild one, because it was combining RDF, distributed systems, and ant colony optimization. Hence the ants. It was wild, but I felt at some point that I'd rather do a bit more query processing stuff in that very weird context. And then somebody said, what are you doing in this community of ant people? You should probably go to VLDB with this research interest of yours. And so I wrote a paper about the crazy ideas with the ants and sent it to the VLDB 2011 PhD workshop, which was in Seattle, I think. And I got there and I went to a talk. I think it was the first talk that I've ever listened to at VLDB, which was the group join from Guido and Thomas. And right then and there, I thought, this is so awesome. I would like to work on this kind of stuff going forward, because yeah, it was this wonderful combination of thinking about something in abstract terms, but then also really showing it in a system how that it makes a big difference when you group and join. I don't know. I also really, when I looked this up again, I found this sentence in the first page. It's like, we strongly believe that no DBMS can do without it. And I really love this sentence. I fear it probably won't survive today's reviewers, but it's bold statements. That's good. And it also had this big systems component, because it was really about making a difference in the real world, and also maybe tackling a chunk of the field of databases that really no one had looked at before, right? Like there were lots of join papers, but there was, and I think not a lot before that on the group join. Okay, so then for various reasons, I came to Amsterdam after finishing the PhD, and I looked for a job in databases, and I found something called the CWI. It happened to be hiring, so I sent Stefan an email and said, okay, can I work for you? And he said yes. As Martin has mentioned, I'm a researcher at CIDR. I'm co-founder and CEO of DuckDB Labs, and I'm a professor at Radboud. To finish up the backstory, I really like to thank Stefan and Martin for taking this giant gamble on me back then, because I had like 0 database papers, right? And I was applying for a postdoc in I would say, pretty serious database group, and they said, sure, which today, I don't know whether I would have done that myself. Yeah, so it's kind of a good memento for like future hunters to remember that back then that was okay for myself. As Marshall has mentioned, the reason I'm probably here is because of DuckDB. For those who are living under some sort of rock, what is DuckDB? It is a in-process analytical data management system. So DuckDB speaks SQL, it's pretty normal. It has a vectorized execution engine as pioneered by Peter and Marcin. And we like to call it the SQLite for analytics. And DuckDB came out of the database architectures group at CIDR. And this is why I'd like to talk a bit about developing systems in academia. And this is my personal view. Obviously, there's other people who have done this, but I think it's nice to kind of describe a bit the genesis and the various observations on the way. Let's start with the good. So this talk has 3 parts. It's the good, the bad, and the not so the duckling, essentially, as you can remember from the title. Let me start with the good. What is good? Postgres is good. I think I was looking for a good example that is sort of undeniably good for a systems development that came from academia. And why Postgres? And I really don't mean to diminish anyone else's stuff. It's just that this is the most obvious example for this talk. So Postgres, as you know, came out of Stonebreaker's research group way back when. Somewhat obscure beginnings, and many people don't notice, but it started off in life as an object-oriented database system. And if you spend a lot of time reading its source code, which for some reason, I'm sort of, I don't know how you guys say, damned to do a lot, you actually can see a lot of these remnants of this object-oriented thing. For example, maybe in case you don't know this, in Postgres, like every type, types are super dynamic, and you just declare a type and give a bunch of callbacks to write into disk and read and so on and so forth. And I think it comes from this sort of time where everything had to be object-oriented. 94 style, which was different, obviously. Why is Postgres such an example for the good? Because it has really made a massive impact. And it's even more surprising that I think the most impact it had was in the last 10 years, which is like way after its original inception. And I think it has really revolutionized or democratized this transactional use case, the traditional database use case, because now everybody can just take Postgres, install it, and you basically have a basis to build your application on. And that brings me to impact. I think we can be rightfully proud that some very successful systems like Postgres have come out of the database research field. Personally, I don't really care about citations and paper count and things like that. As a person, I want to make a difference in like how data is being analyzed in the world. That's a very sort of lofty goal, I admit. But I think that's actually quite common for the people in this room. So then we can think about if that's our definition of impact, what is the the means to do that? And I think this, and of course I'm preaching to the choir, but in this particular community, which is of course a subset of the larger database research community, but I think making systems is a very it's a very powerful way of having impact, especially if those systems get widely used. And I think that is really also something that I would like to discuss with you, how the steps, what are ingredients to really make this impact in sort of building a system, getting it used, this kind of stuff. The downside of building systems instead of writing papers is that, and we've heard this already in the conference, is that this the field is slowly adapting to also recognize these kind of contributions. I'm going to talk a bit more about it later on. This concludes the good. Let's talk about the bad. I really like this bad guy. It's one of my favorite bad guys in history. Let's talk about the first part of the bad. So this is a very bad painting that I made. And it was part of a Bob Ross workshop, right? That we did for science. And it's here because I think building systems in academia is actually like a happy little accident, right? It's really not part of the system, if you want, of the academic system to encourage making systems as in database systems. We are all very happy if they happen, but it's not by any means something that's systemic. So it's an accident or an anomaly that sometimes in some places, for some reason, people start building things instead of, I don't know, writing LaTeX. And I think that's the first kind of observation or point that I'm trying to make here is that if systems design or development, serious real-world systems development happens in academia, it's an accident. And there's also a bit of another side to this, because this community specifically really values systems contributions. We also get a lot of systems simulations, as I like to call them, or fake systems, where because it is extremely easy to write in your paper how you have implemented this in an end-to-end thing that is like super serious and runs SQL and whatnot. But if you then look at the source code, if it's available, you end up with, you see like some Python scripts or something like that. I think that has happened, or you see something that is hard-coded TPCH and that's it. But in the paper, there's this very, very serious description of how serious this all is. And I think it's maybe a bit of reviewer pleasing or something like that, because we like these sort of things, but I don't like these things. Because they tend to be immediately abandoned after the paper has been accepted. And yeah, so there's the second point that I'm trying to make here is that like we should stop probably making these system simulations. That's a bit of a side point. Okay, a losing game. That's so we've heard on Sunday that Martin liked to make metaphors. So I've tried to follow his good example and put a lot of metaphors here. Building systems in academia is a losing game, and it sounds really sad, but I think it's true. And why is it a losing game? Because it takes an enormous amount of time. I think people that have done this in this room, there's a couple, they have an idea of, okay, how about this? They have an idea how much time this is, and it's years, and you don't have an idea of that it's going to be years without having tried this. And I certainly wasn't, how should I say, we went for it, but it's like part of my personality to kind of jump without thinking about the consequences a lot. And I think if somebody told me, like, it's gonna take you 10 years, and I was like, nah, no way. I think it was Peter maybe. But this is also a part of, you have to ignore this kind of thing, because if you really think about how much time this is gonna cost you, you will never start. But but it's gonna take you this time. And in that time, unless you're some sort of karate superhuman, it's going to be very difficult to write a lot of papers. And that's going to be a problem, because you are gambling that this thing is going to work out, this system that you're building. You're not doing what is expected of you. And I found this, and then Stonebreaker himself has actually said this, I think, in his ICDE 2018 keynote, like Postgres would be impossible in the current climate. And I think that's sad. So it's a losing game. Because it is a losing game, like it's institutions generally don't like this, right? Because somewhere up the food chain in your institution, there will probably be a paper being counted. And even if your group leader isn't that, and even if their boss isn't that, there's going to be some department head that's going to compare all the research groups based on impact factor, which is interesting, but it's going to create this negative incentive to actually build something. Because of course, this paper counting person up there will have an influence down chain as well. So, but I think the worst thing, because it is a losing game, and it's actually more likely for your system development to not go anywhere than to be successful, it's a giant career gamble, which gambling, losing game, not a good combination. You're going to lose all your stuff. If it works out, you gamble. They invite you to give the CIDR key, which is nice. If it doesn't work out, you have not written papers for a couple of years, or not a lot, and you're actually going to be, probably in trouble or challenged to find, maybe a professorship or something like that. Why is it more bad stuff? Sorry, this is not a very uplifting thing. The uplifting is later, okay? I promise. Funding is also a bit tricky. I mean, inside of a research group, if you're trying to build a system in academia, if you're inside a research group, you can't use grants, right? This is what we did. We got some grants, we got some gifts from industry to build DuckDB. But you cannot pay market rate for developers. Now, this is sometimes you are very lucky and you have people that work together with you because they like working together with you, and they will deal with the low salary for personal reasons. It's very honorable, but I always felt that was a bit problematic from a kind of fairness perspective. If you think about it, like, these are people that are doing things that in industry are extremely well-paid positions, and here they are doing the same thing, but for a postdoc salary possibly, or something like that, right? So I think it's really problematic. And again, because you're gambling, if that doesn't work out, they have to go. Their research career is also going to be in trouble if they were to want to go in that direction. So that's a bit problematic. So is there any sort of recipe to fix these bad things? As I said, I don't want to only complain about things. I mean, it would have been. I was thinking about, should I just make this giant rant, but I also want to be constructive. Some of my detractors claim that I'm never constructive, but that's just me. What are things that we can do? What are things that we can do? And I think for systems people, we can think a bit about what we have a choice of what to work on. And if you this is one of the things, like, every year when the DuckDB or Sigmod or CIDR programs come out, you scroll through it and you look for papers, and there's interesting things there. But I've also noticed this weird effect that there are these topics that seem to be extremely popular, but I've never seen anyone implementing anything like that. So I've looked this up. There have been 78 top K papers in DuckDB and Sigmod over the last couple of years. And not that I want to, maybe somebody in this room is really into top K and wants to, chase me off the stage or something like that. I'm not saying we shouldn't be working this, but 78 is a lot. I looked up how many papers actually deal with the problem of storing strings in databases, and there were like 7. And if you think about this, it's totally mad, because strings are one of these things that is, in the real world, is this huge problem. We don't know how to deal with strings, really. There's like very little research done on how we can deal with the fact that most of the databases that we actually have are full of strings, right? Like, there's not a lot of that. But if we did, we could make a system that does this better and actually make an impact. The same is true for nested types. For some reason, maybe it's out of loyalty to Cod and friends, we don't really take nested types seriously as a community. At least maybe it's because everybody got burned with XML, and therefore it's like no longer looking at this. This is entirely possible. But thanks to, I think, Google basically declaring that joins are evil and everything should be nested, we have these things now where we have deeply complex nested types in tables, and there's very little research on, for example, how to efficiently process queries on this stuff. There's Parquet, right? I know as a research community, this is like, it's a file format, and it's like something that's there, but it's such a huge thing in the real world, yet there is nobody who's gonna find out, maybe how to how to read this quickly, how to write this quickly. There's really nothing there. But if you did, you could make, a big impact with that. And there's lots of other stuff like protocols. I mean, we have at some point complained about protocols, and this was the first time anybody has ever done this. There's a paper about window functions that was the first in its class from TUM that totally shocked me when I found out that it was the case, because that's such a big thing. Sorting, one of Lawrence is here, he's just written a paper about sorting in databases, and there apparently has not been a lot since Götz Graphic somewhere in the 90s to talk about sorting databases. Like, this is mad. Why are we not looking at these weird topics? Because that's something where we could really make a difference. If you do that, though, people get excited, and I think that's one thing that we learned, for example, from this protocols paper, is that we worked on this, it got accepted, thankfully, and people were really excited that this is being addressed. And if people get excited, you can probably build something in that space and get people to use it, and thereby, create a nice impact that you could have. I also created a picture to illustrate this problem. So if this is the database research field, we kind of work on this thing there inside this tiny subset. We also like to, work on other things like ML. Sorry, Sebastian. That are outside this field, in my opinion. But we are also like to publish rejected NIPS papers at DuckDB, which is one of the things that I think needs to stop. But we are ignoring like this large space here, where there is a lot of gains to be had and a lot of impact to be done. Fewer papers, I think that's not something that I could do anything about. I cannot change the way the higher echelons of our field work. But I would like to propose to create a non-professor career path at academic institutions. I'm not going to change the system because I know like the chances of that are low, but maybe I have enough, maybe I can inspire people to add something to the system. That seems to be like easier. But why don't we add a non-professor career path where there is just, if you are somebody that's a software engineer that likes to work on systems and research, why don't we say, okay, listen, we're gonna give you a path that is gonna basically work out for you long term, so you can continue creating impact through systems. I would like to tell you an anecdote. So maybe you know that Python was invented at the CWI, right? It's one of its claims to fame. And Guido, the creator of Python, actually ended up leaving the institute in a bit of a, how should I say, like a bit angrily, because there was no place for him for what he was doing. And I think that's, despite there being a PL department at the institute, like there should have been space there, but there wasn't, because it wasn't about research, it was about hacking around on Python. And I think we need to give people like him or people in our field a path towards a career that isn't about becoming a professor. I want to talk about open source. As many, including our work, many of research is funded by taxpayer money, right? And one of the easiest ways of giving back something to society, in my opinion, is to just publish what you build as open source. Everyone can benefit. We had this discussion in the startup panel yesterday. Is this a good idea for your company or not? And I admit there are different sort of ways of it, but if it's taxpayer funded, I think there's a moral obligation actually to make things open source, because that way, the general public can benefit. And it's also much more likely that what you're building can actually advance the general practice of data management out in the wild, because the thing you build is not disappearing in a single company, and basically only that company then can use it. Here I have an error in my slides, so I will skip this. So here, this is funny. This idea of this slightly communist idea that I have about open source is was just described at length in the Dutch Financial Times, the Financieel Dagblad, on last Saturday actually, because it was because there was such a radical idea, and I thought it was kind of funny that the financial sort of newspaper would talk about would publish this idea of maybe we should not take taxpayer money and make it disappear in companies. Okay, that was the bad. Now we talk about something more uplifting, which is the ugly. No, we're going to talk about the not so ugly Duckling here. And again, I would like to start with an anecdote. So who here has used R? Show of hands. That is a large crowd. That's a large amount. I think that's impressive. So way back when, after Stefan took a gamble on me, when I started at the CIDR, I was looking around for things to do. And since I knew R and there was MongoDB, and I started working on a R connector for MongoDB. It's actually quite a natural match. Analytical database management systems and the R language, because one of them is very good at sort of detailed analysis and statistics computation. One is very good at like brute force crunching of large amounts of data, and you can actually make very nice combination of these two things. Because I was making something in R and I thought it was useful, I started going to the R people's conferences, right? And talk to the people. It's really weird concept. I know, it's database people. So I talked to the people, and they hate databases. They were really, and Mark has already described this in his side talk a couple of years ago. Like they hated databases. And I was totally flabbergasted. How can it be that the fruits of our great and hard labor, data management systems, are completely ignored by this community, which has an obvious sort of utility use for it, right? How can it be that they hate us so much? Of course, I took it personal, right? And not only did they hate us, they built their own things. Like they built very shoddy, maybe I should not say shoddy because it's on Zoom. They built very limited replacements for it. So they would have query execution engines, but they were single-threaded. They would have like some storage sort of systems, but they couldn't deal with updates. They would have query languages of sorts that are based on like angle brackets and commas. It was not pretty. But why was that? Why did they hate us so much that they felt the need to build their own replacements? And again, I'm gonna go into Martin metaphor land. Why is it so painful? So we have to see where the pain is. I think that was a good sort of how should I say? That was a good idea. And if you think about it, using database management systems can be very painful. As somebody who has installed, I think most database management systems myself on a cluster without root permissions. There's Niels. It's Niels' fault. You really get into this, you really build hatred yourself for these things, right? Because they have, like installing something like DB2 on a Linux box is a total pain. Also, once you realize that you cannot actually install Oracle and DB2 on the same box for some reason, they overwrite each other. It's beautiful. You have to configure this thing. You have to set up a schema and so on and so forth. You have to deal with data ingestions. It's different everywhere and painful everywhere. They have like these browser war query dialect changes and all these things. You have to deal with unpredictable performance. It's really not pretty. And I think the reason why the R people disliked us so much was because we were not seeing this and we were not addressing these pain points. So where are the pain points in the real world? Well, to come back to my Venn diagram here, database research happens here. I would claim we are really ignoring where the real pain is, and that has also really informed our work. I think it's one of the guiding principles of DuckDB, or the way how DuckDB was created, to basically just address where it hurts. So we should treat it. So the R people kept complaining that they said, oh, like your client protocols are slow, so we mentioned this already, we fixed that. But they kept complaining. They said, okay, we really don't want to deal with a separate server client kind of system. So we said, okay, we will need to probably dump the client server architecture entirely. So we created a prototype called MongoDB Lite, which worked, sort of. But the important part was about MongoDB Lite is not whether it worked great or not. It got people excited. And I think that is, again, you know, that is what I mentioned earlier about the weird topics. If you can get people excited with your weird prototype, you get some sort of indication of what you're doing is worthwhile. And because we got this feedback that, you know, this can actually get people excited, and not just database people, but, you know, our people, which hated us. So that was good feedback. We've decided that, okay, it's probably going to be a full rethink and rewrite of what an analytical data management system is in 2018. And I've mentioned before that building systems in academia is a losing game, and it's an anomaly if it, or a happy accident if it happens. And why did we try this regardless? And again, it's a total anomaly. I had just gotten tenure at the CIDR way earlier than normal due to quirks in Dutch labor laws, which is always a good sort of thing. And Mark had finished the papers for his PhD, but still had contract time left. So we could afford to gamble a little bit because we both were like, okay, nobody could fire me anymore for not listening to them. That was a good thing. And Mark was done, and you know, would get his PhD regardless. And I have to then also acknowledge that the CIDR database architecture school, of course, is a special place in that sense that the usual rules maybe don't fully apply. It's not a university, right? So it's a research institute. It's, you know, especially we were surrounded by people that were very supportive of us. For example, Peter, you know, set up us with people at Facebook that ended up giving us a grant so we could develop DuckDB in peace. That was really important for us. But to come back to this whole pain thing, I would like to tell you also about this long-term process, which is very rewarding. DuckDB has been public on GitHub since like 2019. We started promoting it. Some very, very brave souls in retrospect started using it, which is like, I mean, if you look at the first couple of issues on GitHub, it was like, yeah, it exploded and took everything with it, but it's really exciting. This is one of the issues of in-process data management systems, is if they go wrong, everything is dead, right? Because they run in a process, if they crash, your process is gone, and that means your, you know, your Python shell is gone, your, you know, and with it, your R shell is gone, and with it all the state that you may or may not have added, and that people don't like that a lot. But the brave souls, they reported back to us and said, okay, this is working, this is not working. And what it created was this direct, I would say, like the pain hotline, if you want. So we could have a direct iteration cycle, and we would hear from users, from the brave souls, what was working, what wasn't working for them. And loads of interesting problems came up that way. Just by people using it, reporting back, and this became this iteration thing. So for example, you know, like there were things about window functions. We had always ignored window functions and didn't think they were so important. But people really like, okay, sorry, but I mentioned I was working on ants, you know, I'm not taking that seriously, to be taken that seriously about window functions. But what happened is that a lot of people started demanding window functions on our GitHub. So we were like, aha, interesting, I should do something like that. Or people started describing these issues that they had about DuckDB running out of memory when an intermediate in an operator would outgrow the available memory, which led to a whole PhD project of out-of-core processing for analytical data management system operators, for example, you know, offloading to disk with enjoins and things like that. And so we could build this iteration of fixing things and then hearing back of what the current biggest problem is and fixing things. And that's really, it's been really, really rewarding. Some of my clickers stopped working again. Oh, there it is again. You gotta love Bluetooth, right? So I also want to talk about single node. So I think the common wisdom in the research field, since the Hadoop paper, but probably somebody else has a better insight on that, was that if it doesn't scale out, it's useless. And this was an actual review comment I got, by the way. But there's, of course, as we know, there's quite a lot of complexity to building distributed scale-out things. Yeah, all this, like, go back to the pains, you have to deal with setup management and error handling, debugging, and so on. We actually, Mark and I were teaching a course about teaching business people how to run Spark. And I think as the result of this course was A, okay, we got paid, which was nice, but B, we found out just how much, how much can go wrong in this kind of thing, right? Because you have people that had like no formal training in computer science or any formal training in computers at all, trying to get something done with Spark, and it just blew up constantly. But that's just a side note. We said, no, let's just go for single node because data sets are not as big as people think they are. That was a pretty big gamble, I think, in 2017. But there was this couple of years later, this paper came out from, I think Anna is maybe around. Yes, TF Data. It's a TF Data paper from Anna, who worked at Google, I think, when she worked with this. Yes. That basically said that, okay, at Google, 90% of all analytics workloads operate on less than 1 terabyte of data. And I thought that was like, this felt so good to see this, because it was this confirmation of our sort of suspicion that the data sets may actually not be as big as people think. And we thought this single node idea, we probably have to sort of hunker down for a couple of years until people start believing us. And I personally thought this is going to be like the hill I'm going to die on eventually. But it turns out that it didn't take that long. And now we have people from Andreessen Horowitz describing what a good idea single node is. And I think that was quite funny and quite unexpected in retrospect. Well, there was also this thing when Mother got this funny announcement that somebody put it up on the NASDAQ thing on Times Square, which also I thought was pretty awesome for an idea that had been decried as useless by reviewers just a couple of years earlier. Okay. I also want to talk about little things. I know this is like something that is not, it doesn't sound exciting. But there is a ton of things, 10 minutes, very good, thank you. There's a ton of things that are irrelevant in research, like whether or not your research system has a packet, like a installed size of 2 gigabytes or not, doesn't really matter. Like, you're making a point of not trying to fit it on a small sort of system. It also doesn't matter whether it only runs on one version of Ubuntu. I mean, hell, there are commercial systems out there that only run on one version of Ubuntu. I think this whole Docker nonsense has made this way worse and somehow acceptable to basically do that. But I mean, I could rant about this. Backwards compatibility for a research system doesn't matter at all. You know, whether or not your binaries get corrupted after every release or not, doesn't matter. But what people forget, I think also in our community, because we only talk to database people, many do, is that database users are not sysadmins, they're not programmers, and they're certainly not database researchers. And we talk to a lot of users that are biologists analyzing frog data, okay? And for the people analyzing the frog data, the little things are extremely important. For example, dependencies. Thanks to Niels not allowing us to install stuff on the cluster, we really learned how to deal with, how to hate systems that had a lot of dependencies in running. And again, you know, it doesn't matter so much if it's in a container because you just install this giant Clang thing, but it really matters for the frog people, right? Users are generally not able to install dependencies, so DuckDB doesn't have external dependencies. We only need a compiler to run. We also didn't go for the most recent C++ version, for example, for the same reason, because it's unlikely that Frogman has C++ 27 compatible compiler, I suppose. Also something stupid like single file, right? Like databases love to create these giant zoos of folders and files that, you know, maybe or maybe are not important to the data that you store, right? Like if you scroll through like the folder structure created by like MySQL or Postgres, there's like files there that have like obscure names, and some of them are like irrelevant and you can be deleted. By the way, side note from my MySQL days, I thought when I first used MySQL that the log was clearly for log files and therefore could easily delete it. That was not the case. But because that is such a pain for users, we decided to have single file format. It really made it easy to email DuckDB database around or check them into GitHub. Parquet, I mentioned already, we are ignoring Parquet. DuckDB has a built-in Parquet reader. It is the standard now, whether we like it or not. There's just no way around it. Footprint, DuckDB is like 25 megabytes compared to like many hundreds of megabytes of other things. I think it matters. I think it matters also in terms of where you think can be used and what kind of systems get installed. These are little things, and I would like to urge you all to look at the little things as well. These things matter, especially if you want to come to the next point, which is promote your system. And this is something that I know that most people in research, they don't like doing PR. I also don't like doing PR. It feels quite dirty, honestly. You know, to go out there and say, you should use this is awesome, is something that I would, rather leave to the department of marketing or something, or sales, right? Like these people have different mindsets and they love saying things like that. I don't, but it is actually critical. If you do not if you do not promote what you're doing, you cannot interact with users, and there's no way for you to talk to them. Remember, we had this discussion line open with the R people and could really get really good feedback early on. So we used a combination of like social media, blog posts, and Hacker News sort of shenanigans to get up there to promote DuckDB, and it worked out quite well. It is really not rocket science. Join algorithms are more complex than this. You can do this, but it's really important for this kind of thing. You do need something that is substance, so it actually needs to be doing something, and mass appeal, right? So it really makes a lot of sense to promote something that is extremely narrow, interesting to two people. But remember the research topic Venn diagram. There's lots of things that many people care about that you could do. Okay, very briefly, we started a spin-off to fix the can't pay proper salaries problem. DuckDB Labs, we mentioned yesterday, it's a spin-off that is not VC funded, it's self-funded, and it basically provides services around DuckDB. More on that if you want in detail. I would like to talk a bit about the outcome of all these things, like looking at topics, looking at the little things, looking at where the pain is. The outcome of all this is that DuckDB has about 2 million downloads every month at the moment. It has loads of GitHub stars and activity on GitHub and such. It is actually quite scary in that sense. You know, like it used to be that we would just screw around on DuckDB and then every now and then something happens. But now there's so many installations that we actually have to pay attention to our releases or something. It's very interesting. We have seen two main use cases of DuckDB emerging, and that was also interesting because we kind of built it to make the R people happy, if you in the very sort of general sense. So it is used to scale data science workflows in R and Python and so on. But we also have been surprised to see DuckDB as a building block for large-scale data pipelines in very big companies like Facebook, Google, stuff like that. And that I think was really interesting to see how this thing that we built to solve this pain of the data science crowd has this accidental, also extremely good applicability in other fields. And the only way you find out about this, of course, is by getting it used. Here is a chart that Peter made that showed the download development of DuckDB on Python over the last couple of months. It's been quite astonishing. Okay. let me finish up. I first would like to thank Mark. This is a picture of us looking at our new office. I think you can tell how pleased we are. Mark, you have been my partner in crime, as I like to call it, for many years. You are now the co-founder and CTO of DuckDB Labs. It's been a privilege working with you. I would like to really acknowledge you there. I would also like to acknowledge Peter. Specifically, is extremely supportive from the beginning, making us feeling more encouraged to take the gamble, as I mentioned, and also helping us with a lot of entrepreneurial questions, which is not necessarily in the skill set of a department head of the CIDR, I would say. I would also like to thank a bunch of other people, Pedro, Lawrence, Richard, Sam, Tanya, and Thijs, who are, some of them are, I think all of them are working with us at DuckDB Labs. And with that, I'd like to thank you for listening and happy to take questions.